For our first extra practice problem, I'm going to show you once again why you want to simplify your fractions before you start simplifying your radical symbols. So I am going to not simplify my radical first, and I am just going to leave my problem as square root of 3 times square root of 2. 12 is going to turn into square root of 4 times the square root of 3. Now I do know that the square root of 3 and square root of 3 can be divided to equal 1. And I do know that the number 4 can simplify into 2. And so I end up getting square root of 2 over 2. And then I am done because the denominator is not an irrational number. Therefore, this is in simplest form. However, if I simplify my fraction before I start by dividing both of these numbers by 6, I end up getting the square root of 1 over the square root of 2, which is equal to 1 over the square root of 2. So my problem is actually done quicker once again, except I have an irrational number in the denominator. And I want to make sure I always rationalize the denominator. I need only rational numbers in the denominator. So I'm going to multiply by the irrational number in the denominator to the numerator and denominator together, because the square root of 2 divided by the square root of 2 is equal to the number 1. And I can multiply something by 1 and never change it. I end up getting square root of 2. This times this, or square root of 2 times itself, is equal to 2. And I get the same answer again. So when we're solving these problems, you want to simplify your fraction first, and you want to make sure you rationalize the denominator if necessary. For this problem, we have already simplified our irrational down as far as we possibly can, but the denominator has an irrational number in it. Therefore, I need to rationalize the denominator by multiplying both of these numbers times the root of 5. 20 times the root of 5 is going to stay like this, but the root of 5 times the root of 5 is equal to 5, which looks like it should be done unless you remember that 20 divided by 5 can be simplified to be 4 over 1. So I can write it like that, or I can just write it like this and ignore the denominator because dividing by 1 doesn't change a number. So I have one last problem that I want to do before we send you off. We have kind of a crazier problem here. Square root of 3 over 2 times the square root of 6. Now there's two ways to solve this. I'm going to show you the one that probably would be more common right away, which is I'm just going to rationalize the denominator right away by multiplying both of these numbers times the root of 6. So my top of my fraction becomes square root of 18. The bottom becomes 2 times 6, which is equal to 12. Now, the problem here is that the square root of 18 can now be simplified into the root of 9 times the root of 2, all over 12. This becomes 3 times the root of 2, and 3 divided by 12 is equal to 1/4. Therefore, my final answer will be the square root of 2 over 4. Now, the problem here is that this ended up taking a lot more time than it needed to, because if I notice that the square root of 6 can be broken up into the square root of 3 times the square root of 2, I can actually remove the square root of 3 before I start. So I get 1 over 2 times the root of 2. So now when I rationalize the denominator by multiplying both of these numbers times the root of 2, I end up getting something that's a little bit simpler right away. This is equal to 2, so my answer is already done. So I actually saved myself 2 full steps by breaking up 6 into square root of 3 times the square root of 2 right away, which we normally don't want to do, but in this case it actually made it a little bit easier. So rationalizing the denominator is not an easy concept. There's a lot of small steps in there. The nice thing is once we get to this part, there's not a lot of difficulty we can really add to these problems. As always, if you have questions,